Question 1e, we're looking for the sum of the series 1 over n times n plus 1. What we're going to do is compare it to the integral of 1 over x times x plus 1. To do this, we need to recognize it is a partial fraction. We cannot integrate it the way it is, so we're going to have to set this up as a partial fraction. So I want to solve for my a and b coefficients, so I get a x plus 1 plus b times x, and that's going to be equal to 1. Okay, the original 1 that was in the numerator here. Okay, so I'm going to end up with ax plus bx. I'm going to group the x terms like this. Actually, I'm just going to keep this the same. So plus bx and that's going to be equal to 0, since there are no x terms in that expression. And we then get a is equal to 1 when we match the coefficient of a. We know that we get ax plus bx plus a. The a matches the 1, so a equals 1. The second equation is going to be a plus b is equal to 0. That's going to be equal to 0, so that makes our b value equal to -1. Okay, so now we have our partial fraction, and we can set up the integral. So we're looking for the integral of 1 over x dx. Okay, and I need to set this up as a limit. So this is a limit as a approaches infinity of 1 to a plus -1. So I'm just going to make that minus. So make that minus the integral from 1 to a of 1 over the b was x plus 1. Okay, so doing the antiderivative of this, we're going to end up with log the limit as a approaches infinity of log x from 1 to a minus log of x plus 1 from 1 to a, and then we're going to plug in our a values. So limit as a approaches infinity, this becomes log a minus log 1, which is 0, minus log a plus 1 minus log 1, which is 0. Before we apply the limit, we should really put those log terms together. So we get log of a goes to infinity, and log 1s are 0, so we're going to end up with log a minus log of a plus 1, so that a plus 1 ends up in the denominator. Okay, and at this point, we can apply the limit. Well, the limit of a over a plus 1 is 1, so we end up with log 1, and that is equal to 0. Again, so this then means then that it is finite So this is convergent. So this is finite and it is convergent.